Chapter 8, Discrete Random Variables. Now we are going to study about how to construct a probability distribution table, where we can define the discrete random variables and their corresponding probabilities, and how to write down a probability function. Look at the description. A discrete random variable can be specified by giving the set of all possible outcomes of the experiment or the possible values of the random variable and the probability with which each occurs, so the corresponding probability. To specify a discrete random variable completely, you need to know its set of possible values and the probability with which it takes each one. You can draw up a table to show the probability of each outcome of an experiment. This is called probability distribution. Okay, look at this example, which is a fair die is rolled and the values are from 1 to 6. Now, if we want to construct the table, this is how it will look like. We have a small x, which are the values of the random variable. The numbers are from 1 to 6. Then we have the probability for each event to happen, which is probability of capital X equals to small x. We know that here we have the number of outcomes over the total. That means the probability for each event is 1 over 6. So this is the form. Notice that in the first row we have a small x and it represents the values of the random variables. In the second row we have the corresponding probability. This is known as the probability distribution. However, we can write a different form for this probability. As you can see, the values for the random variable range from 1 to 6 and they all have the probability of 1 over 6. Thus, we can write the table in the form of probability of capital X equals to X equals to 1 over 6 for X equals to 1, 2, 3, 4, 5, 6. This is the probability function. However, when it is in the form of a table, it is called probability distribution.